So gases and solids can both dissolve in liquids, and the way in which they dissolve in a liquid can be influenced by certain things, certain factors. For gases, I've outlined 4 different factors. The first thing that influences a gas's solubility within a given liquid is something called Henry's law. And Henry's law is a formula that relates the solubility of the gas. And the higher the pressure, the higher the solubility. For example, suppose we have a soda can. Now, how are they able to get so much gas in the liquid in a soda can? Well, that's because they decrease the volume to such a small volume found above the liquid that the increase in pressure causes solubility of the gas to increase. And so a lot of the carbon dioxide found above the liquid in a soda can dissolves in the liquid. But when you open the liquid, the pressure decreases because there's an influx or an outflux of molecules out of the can, and therefore the outflux creates a lower pressure. A lower pressure means solubility decreases. A lot of the molecules will leave the liquid, and you will get a stale tasting soda. The second thing that influences solubility of gases is temperature. The higher the temperature, the less soluble something is, or a gas is. And that's because it has more kinetic energy, less likely to stay within the liquid. Size also influences solubility. Larger molecules experience larger van der Waals forces and tend to increase in solubility. And that's because a larger or heavier molecule will be pulled more strongly in the liquid, and therefore will be more likely to dissolve within the liquid. Finally, gases that chemically react with liquids dissolve more readily in a liquid. Now, for liquids and solids, it's a little different. Now, liquids and solids are not compressible, and therefore changes in pressure has no effect on solubility. So there is no Henry's law for liquids and solids. However, temperature now increases solubility. For gases, we saw there is a decrease in solubility when the temperature is increased. For liquids and solids, it's the opposite. And that's because, for example, when salts dissolve in a liquid, entropy increases. Entropy becomes positive. And so if we look at Gibbs free energy, at higher temperatures, this component becomes positive. At higher temperatures, this guy will be negative, so this guy will be negative. Therefore, the reaction will be more spontaneous.